Okay, let's roll. A bat hits a moving baseball. If the bat delivers a net eastward impulse of 0.9 Newton seconds, and the ball starts with an initial horizontal velocity of 3.8 to the west, leaves with 5.3 velocity east, what is the mass of the ball in grams? Okay, so the ball is initially traveling 3.8 to the west. So we will describe that as minus 3.8 is my VI. And my VF after it's hit is 5.3, and that's going to be positive, right? So your first step is to find your change in velocity. So it's going to be VF minus VI, 5.3 minus 3.8, which is 9.1, right?
Yeah.
Okay, so it changes by 9.1 meters per second because it's going from one direction to another. That's sort of a main concept there. All right, then what is the mass of the ball? So now we're going to go fat equals nav. The force is, now no, we don't know the force, we don't know the time, we just know the impulse. So the whole thing over here is 0.9, right?
Yeah.
So now it's just mass times, oh, this is actually, yeah, kind of like what Mike said, kind of easy, isn't it?
Yeah, the second one.
Yeah. So 0.9 all over 9.1, which is about 100 grams, roughly?
98 grams.
98 grams? Seems a little light. Okay,
Let's do two.
let's do two. Okay. A 500.5 kilogram ball is dropped from rest at a point of 1.2 above the floor. The ball rebounds straight upward to a height of 0.7. What are the magnitude and direction of the impulse of the net force applied to the ball during the collision with the floor? Ooh. Okay, so you need to figure out two things. How fast is it going? What is the final? Now I understand what you were trying to ask. What is the final velocity once it falls 1.2, right? So that's going to be Vf squared equals Vi squared plus 2AD. 0 plus 2 times minus 9.8 times my distance of 1.2. And I'm going to go get one of my new calculators that I got from the office. Quite excited about them. So that's going to be, cut down, 2 times 9.8 times 1.2 equals, and the square root of that. Now this is minus. Do I need to worry, like, does that have to be minus?
So,
It can't be, because you're not going to be able to do the square root thing, right? So it only has to be minus when it matters to when there's sort of an up and down, and in this case, I just need to know how fast is it going.
3 times negative 9.8 and a negative 1.2, then it would work.
That's true. You're absolutely right, Mike. Wow. Good for you, man.
So,
Bob's your uncle. 2 times 9.8 times 1.2, and take the square root of that. I get 4.8. Is that correct?
yep. Yes, sir.
4.8 meters per second is the speed when it hits the floor. Now, somebody was asking either Sean or Alex, I can't remember. This is actually the
Yeah.
initial momentum in the
Second half.
second half, exactly. Right? Now, how fast is it going when it rebounds? So now we're doing sort of the opposite here, right? The ball is rebounding to a height of 0.7, right? So again, let's do it all down here. Whatever. So again, Vf squared equals Vi squared plus 2AD. This time the final velocity is 0, and we're solving for the initial. 2 times minus 9.8, and this time the D is 0.7 and it's positive. .7. So this is not a perfectly elastic collision. There is some energy lost. Where does that energy go?
Heat.
Heat. The ball becomes hotter. In fact, if you play tennis and then, hold the ball, you'll see that the ball is actually warm, right? You'll feel it. Racquetball, I used to play a lot of racquetball at university, same thing. The ball would actually you could feel it was actually softer because it was so much warmer after you whacked it around for a while. Okay, so what is my delta V in my interaction here? So we're going to label this one as, this is the initial minus 4.8, and this is the final, which is positive 3.7. So my delta V is going to be 3.7 subtract minus 4.8. $8.5, right, is the delta V.
That's kind of like I think of the initial velocity.
Do you want me to pause here and see how you make out the rest of the way?
Because once I got there, once I had initial velocity,
You can get the change in momentum. Therefore, the delta P, the change in momentum is m delta V. So we've got 0.5 times 8.5. The change in momentum is 4.25 kilogram meters per second, right? That's the change in the momentum. And the question asks, what's the magnitude and the direction of the impulse? Isn't impulse equal to delta P?
No, not delta. Delta.
Yes, because fat equals MAV, right? And m delta V is delta P, and fat is equal to J. The impulse is the change in momentum. So all you do is you just say J equals 4.25 Newton second in which direction? Up.
Crap.
It's actually kind of easy.
No. When you start with that.
it's not that bad.
I'm Momentum Boy. I solve problems in my spare time.
You gonna hang that up?
It's over there. It's on the bulletin board. I tweeted it yesterday, too. I didn't get any response. I was very sad. I cried myself to sleep.
Good, Brian.
All right. Give yourself, on this question here, I would say that this would be
Like 14 marks.
1 mark for that, and 1 mark for that, maybe 2. Well, what else is there to do here?
Oh, that's the first one you actually asked.
And this one here, I would say 1, 2, 3, 4, 5.
Stop, so Mr. Ray talks about doing questions, he's just like, yeah, you don't have to get the answer, you just have to do all the